All right, we are on the final lesson, lesson 3 for 1.5. And here's another interesting one. Last time we covered the solutions type of question or investment type of question. And this time we're going to look at something a little bit different. Some parts of this I think a little bit easy and some can be a little bit confusing. So with a tailwind, a plane flew 3,000 kilometers from Calgary to Montreal in 5 hours. With a tailwind means that the wind is blowing with the plane, okay? The plane's traveling the same direction as the wind. The return flight against the wind took 6 hours. So of course, the plane's traveling against the wind, it would take longer because it has to battle the wind and then find the wind speed and the speed of the plane. I took the liberty of completing the therefore statement here. So let P represent the speed of the plane, let W represent the wind speed, keeping my variables simple and easy to understand. P obviously for plane, W for wind. It just makes life a lot easier when we're coming up with our equations. But I want you to understand also, sometimes you get questions like this that'll talk about a canoeist in some of your homework. So a canoeist is paddling in the water, or you'll get a speedboat in the water, that type of thing. And if you, for example, if you put a canoe in the water and the current is traveling at 3 kilometers per hour, if you just drop the canoe in the water, it'll be going down river at 3 kilometers per hour. Right? Now, if you are personally able to paddle, let's say you can paddle 10 kilometers per hour and the current's going 3, you could sit in the canoe and pretty much do 3 kilometers an hour without having to paddle. But if in addition to the 3 kilometers of the current, you paddle 10 kilometers, you're now going 3 plus the 10, you're traveling 13 kilometers per hour, right? And then if you were turning and facing the other way, perhaps, and you had to go upriver against the current, then you would, if you put the canoe in the water, and you would have to paddle 3 kilometers per hour just to stay in one spot. So if you paddle 10 kilometers per hour and you're traveling the opposite direction, you're really only going 7. The 10 kilometers you're paddling minus the 3 kilometers the current's coming at you. So therefore, it will take longer to travel your distance. This is the same type of question. Just be prepared for that in homework. Same type of question, same approach. Okay. So the first equation, sorry, before we get to the first equation, you have to understand this formula. Distance is equal to speed times time. I don't normally like to use the X for the multiplication symbol, but I'll allow it for this one time, make an exception here, okay? So the distance is equal to speed times time. We already know for the first equation, the distance we're traveling is 3,000 kilometers. In fact, if they're flying 3,000 kilometers from Calgary to Montreal, and then they're returning, then the distance for our second equation will also be 3,000. So the distance, that part is easy. The speed that we're traveling is probably the most difficult, but the example I gave you with the canoeist applies to the plane. So the speed is going to be a combination of wind speed and the plane speed. The time, however, will be different as well. The 5 hours will be the short route, and it takes 6 hours on the way back because you're traveling against the wind. So how do we calculate the speed? First, again, just to understand this equation here, use a simple example. To memorize this formula, think of a simple example. If you're in a vehicle traveling to a destination, right? You're traveling 100 kilometers per hour on the highway. Let's say you're traveling to a cottage. You're traveling 100 kilometers per hour and you're in the car for 3 hours. Well, how far have you traveled if you're traveling 100 kilometers an hour for 3 hours? You have 100 kilometers times 3, 300 kilometers. That's your distance. So just a simple example like that will help you memorize the formula. The distance that I traveled is equal to the speed I was traveling at times the time, or how long I was traveling that for. And that's an easy way to remember that. So the speed in this case, if you are with the tailwind, the speed is going to be the speed of the plane plus the wind speed. Just like I talked about before, it'd be the canoeist paddling speed plus the current speed, right? On the way back, you're traveling the speed of the plane, but it's minus the wind speed. Just like the canoeist was 10 kilometers, you're paddling 10 kilometers an hour minus the 3 kilometers of the current because you're traveling against the wind. So paddling, sorry, in this case, plane speed minus the wind speed in this case. Okay, now armed with these two equations, you're probably tempted, just given your math gut and prior experience in math, you're probably tempted to do a bit of the distributive property, multiply 5p times 5w, 6p times negative W. But that's not the easiest path. Okay, what you want to think about here is, remember, when we want to come up with equivalent linear equations or equivalent linear systems, we covered this earlier in the chapter. If I want to do that, I can multiply or divide the equation by any real number. In this case, if I take this equation here and I divide by 5, I will get a new equation, the 3,000 divided by 5. My new equation went 3,000 divided by 5 through mental math. 5 goes into 30 6 times, and there's 2 zeros left over. So 600 equal. And now here's probably the more difficult part. When I divide P plus W times 5, and I divide that by 5, that's a little interesting. People get confused here. I'm going to write it this way with the 5 on the left, 5 times P plus W, because you're probably used to having distributed property from the left, but it really doesn't matter. But I want you to think about the P plus W portion. I'm blanking it out for now. 5 times something. It really doesn't matter what's in the brackets. What's in the brackets is being quintupled, right, or made 5 times greater. So if I divide by 5, that just cancels out the multiplying by 5. That's all that does. And what I'll be left with is whatever's in the brackets, in this case, P plus W. Same thing's going to happen with the second equation when we divide everything by 6. When I divide everything by 6 in the second equation, for this part here, it doesn't matter if I have something in brackets times 6. When I divide by 6, that cancels out the multiplication by 6, and I'll be left with what's in the brackets, in that case, P minus W. So in the first one here, we said 600 equal P plus W because we divided everything by 5. And now I'm going to divide this entire second equation by 6. I'm just going to show my work here. And so my new number 2 equation is going to be 500, because 3,000 divided by 6 is 500, equal P minus W. And now I'm armed with these 2 equations, and they look a lot simpler to solve. So I could decide whether I want to add or subtract. So to do that, I look at my numerical coefficients. I've got basically 1P and 1P here. That's pretty simple. And I've got a positive 1W and minus 1W. If I add the equations, the W's will disappear. If I subtract the equations, the P's will disappear. I'm going to do the subtraction because it's a little more difficult for some of you, and I'll show you why. 600 minus 500 leaves us with 100. And then equals P minus P is 0. And this is where most grade 10s will make their mistake. Positive W minus negative W is the same thing as saying positive 2W. Okay, careful with that. And if I divide both sides by 2, 50 equal W. So I can box my answer there. I'm just going to move this down a little bit, give us some room. And now we have to solve for P. Solve for P. And the easiest equation I can use now will be something like this, right? 600 equal P plus W. And we just figured out that W is 50. So 600 equal P plus 50, sub in using brackets. And now we can skip steps if we like. P is equal to, bring the 50 over, so it's 550. Again, we don't write kilometers or anything like that yet, but we'll save that for our therefore statement. Therefore, the speed of the plane, and here's where it's important, is 550 kilometers per hour, and the wind speed is 50 kilometers per hour. All right, I hope that helped you. If you have any questions, come on in. Have a good one.